We have looked and we have understood how the label encoding works. Okay, let's understand it with the help of proper coding and how we can apply in our data frame and how we can actually use with the help of the coding. Let's go back to our, sorry, let's, yeah. Now, let me print my DF data frame that is, sorry, we have to run this whole cell once more. I'm running it one more time. Yeah. Now we have this column. We had converted our sex column into the, with the help of label encoding into the numerical form. We have seen the example of it. And for the embarked column, we can convert into the numerical data type. Let's try to convert. So first I will write here hashtag label encoding. Now for applying label encoding, what we can do, we can we have to import a class from a function, or you can say a method from a class. So what we'll do, we'll import from sklearn dot preprocessing, sklearn dot preprocessing, import label encoder. What we are doing, we are doing label encode. So from sklearn dot preprocessing, we are importing label encoder. We have imported it. Now we have to create an object for this. This is the class, so we have to create an object for it. So we'll create LB is equal to label encoder. Now what will happen? Whatever the methods function consists of this label encoding, like whatever the functions methods consisting label encoder, it will be can be accessed by your LB object. We run this. Now we want to convert this sex column from male female, that is string data type, into the numerical data type. So for doing that, we'll write like this: df of sex. First it will show you the data. Now this data will be passed into some function to convert it into the numerical form. So we'll write like that: lb dot fit transform. Now fit transform is a method inside your LB object and it accepts some values. So what we are passing? We are passing df of sex value. That is all sex column that we are passing. Sorry, all the data that we are passing. Now, if we run this, as you can see, it is giving me an error array. Sorry, it is giving us an array 101010 like this. And we have seen this with a basic example in Paint software also, like how we have manually converted the each of every value into the numerical form. Now this function is successfully converting all this string data type into your integer data type or numerical value data type. We have converted it, but we have to save these changes in our original column, that is the sex column. So what we can do for that, we'll write like df of sex equal to lb dot transform df of sex. Now what will happen, just run it. Let's see df column. Yeah, now you can see that our sex column has been successfully replaced with 1010 like this. It has been replaced with some numerical values. Let's see for the embarked column also. Now in embarked column, there are few characters SCS like that. For converting that also with the help of label encoding technique, what we generally do, we'll write like this: df of embarked is equal to lb dot fit underscore transform method, fit underscore transform method, and inside that we'll pass our of def of embark. Now see this. As you can see, now our embarked column has been replaced by some numerical values, that is 0, 1, 2, like this. Okay. Now guys, you will think, yeah, we have successfully replaced it with the label encoding and we have got our values also. But what if we wanted the values again? Now what you can do, you have make the changes in the into the df data frame. Now you have to run the cells again, then you will get the value. But there is a other method in this lb class or lb object. With the help of that, we can get back our original data into the form of string. So for that, what we need to actually do, we can just write this again, df of sex equal to lb dot inverse transform. First, we have used the fit transform method that was converting our string or object data type into the numerical form. But if you want to make the changes reverse, you want to convert numerical values into the form of string or object value that you had already. For that, you will use inverse transform method. So for that, we are using lb.inverse transform method. We will pass our df of sex column again, and let's see if we had any changes right now. Now, as you can see here, sorry, see, now there is a one issue. Okay, for this method to be work properly, you have to create a separate object for every column. Now see, with this help of LB object, we have converted both columns, sex column also, embed column also. Okay, now what will happen? Latestly, we have converted our embed column values that was in string data type and we have converted it into the numerical form. Okay, firstly, we had converted our sex column. Okay, now what is happening? If you want to go back and reverse those changes, you have to create separate object for every column so that the values will be stored into that object. Okay. Now what happened into this? First, with the help of this LB object, we have converted the sex column into the form of numerical value. Now in this embark column, after that we have just converted embed column string values into the numerical values. Okay, now this latest values will be updated into that. That's why we are getting wrong changes into it. Okay, we are getting the wrong changes into it. So for that, what we need to do, we need to reverse back the changes. Let's run this wholesale one more time. Wholesale one more time, that will take a few seconds. Yeah, now it has been done. Yeah, now you can see we have fit transform until now. We have fit transform until our df of sex column only. We have not made any kind of changes with embed column. Now suppose you want to get back your own data, previous data of the sex column. So what you will do, you will use that inverse transform method. But remember that for separate columns, you will have to create separate object. Okay. Now let's see what we'll do. We'll write the code like that. Df of sex equal to lb dot inverse underscore transform, and in this we'll pass our df of sex column. Okay, let's pass this. Let's see the data again. Now, as you can see clearly on your screen, we get back our original data and now it's successfully running. No issues into that. So for converting string data into the numerical form, we'll use fit transform method of like a label encoder. For converting back from numerical data to string data type again into the previous form, we'll use inverse transform method. Okay, guys. So that is the thing that we have to do. Let's run this for the embed column also. We wanted to convert that embed column also for the label encoding. So for that, I have to run this cells. Let's delete this data. Let's run this cells again. Let's run this cell again. Have we get back our data? DEF embarked has been also changed. Now let's remove this. We don't need right now anymore. Ultimately, this is our final data. Okay. Now we have understood how we do generally for the label encoding. We have understood fit transform, inverse transform method, both of the method. We understood and we have seen the difference between them. But there is one question for it. Like label encoding, one hot encoding, we have two encoding technique. What is the drawback and what is the benefit of that? Okay. So your label encoding takes less spaces as compared to your one hot encoding, as compared to your other encoding methods. Okay. The first like feature of label encoding, you can say like that, it has it takes less spaces as compared to other encoding technique. Okay. But it has some drawbacks also. What is the drawbacks? Let's try to understand it. What is the drawback actually? Now, as you can see, in embarked column, we have replaced S is 0, C is 1, Q is equal to 2. Now this 0, 1, 2, 0, 2, 2, 1, 1, 0, this value will be trained in our machine learning algorithm. In our machine learning model, these values will be trained. These value will be trained. Now what will happen? As we can see, 0, 1, and 2. We can clearly see there is some mathematical difference between these values. That means this 2 is greater than 1, 1 is greater than 0. 2 will be have highest priority, 1 will be have low priority, 0 will have lower priority than 1 value. Now, where we have to use label encoding, these are the some important questions. Let's try to understand where we have to use label encoding. Okay, you will use label encoding where we need to make some priority. We need to make some priority. Suppose, let's try to get an example. Suppose you are making a priority of subjects. You are making a priority of subject. Suppose you are getting maths highest priority. You want to give math as a highest priority, science as a low priority, and English as a below low priority than your science. Then at that case, when there is a priority kind of cases, you will use label encoding. But whenever all the values is same, means you want to give the object or string values as the same level, like for the male and female, both of them are equal and same, nothing difference, no much differences into that. So at that case, you will not majorly going to use that label encoding technique. Okay, so label encoding technique try to use at that place where the priority is high, where you want to make some priority. Okay, so for that reason, what our machine is going to understand, it is going to understand for the Q. Let's see for the Q. It is going to see that, okay, Q has the highest priority. So means I have to predict the result related Q highest. Result related Q highest. After that, I have to produce the result related C. After that, I have to like give the result related as, so it is having some priority basis. Okay, and that is the drawback of your label encoding. Now we have understood label encoding properly, we have understood how we have to use it, and yeah, whenever we want to train it with machine learning, We have to convert our data whenever we see any kind of object data type or string data type. We have to convert our data into the labeling with the help of label encoding or other encoding techniques. So into the next video, we are going to understand about one hot encoding, and we have to understand, we will see what are the major differences between major one hot encoding and label encoding also. So that's it for today. We'll meet you into the next video. Bye bye, guys.